The question says for the following compounds write structural formula and IUPAC names of all the possible isomers having the number of double bond and triple bond as indicated. Okay, you can see in the first compound we have one double bond and in the second compound we have one triple bond. Good. And we have to write the structural formula, IUPAC name and all their isomers. So one by one we can do it. First one we have C4 H8. Okay, we have C4 H8 is there. Okay, it says it has one double bond. Okay, one double bond is there, means it is alkene. Okay, so first we have four carbon are there, 1 2 and it is 3 and it is 4 is there, four carbons are there. Okay, we attach one double bond, let's say here this is one double bond. Now satisfy the valency of carbon, it is H2, it is H, it is H2 and this is what we have, H3 is there. Okay, compound is ready. Another one we have, we can put the double bond in the middle. So C and C, C and it is C is there. Next time I put the double bond in the middle of the chain. Okay, so again we satisfy the valency of carbon by attaching hydrogen. See here we got another compound, CH3 is there. It is supposed to be CH3. Okay, now if I keep double bond in the next time here, so I will get this compound again. So now we can do the branching. So if I do the branching in this case, let's say it is what we have CH3 and isopropyl group I can introduce and double bond, this is what CH2 is there. Okay, this is the branching. Beyond this branching is not possible. Okay, because limited number of carbon are there. Okay, keep in mind if I think about cis and transform. Okay, so this compound cannot show cis and transform because these two electron densities, these two group are same. Okay, these two group are same, and this compound can also not show cis and transform because these two hydrogen are attached to the same carbon. Okay, look at the double bond position. This side you can consider cis and trans, but this side you cannot consider. It will come like this. Sorry, C it is H, you have C and C is there, double bond C and it is H and it is H. These two groups will be same, but in this case you can consider cis and transform. How the cis and transform will work? You can see this is C double bond C is there. One time we keep H group at the top. Okay, we have CH3 and it is CH3 there. This is what we have cis form. These two same electron densities are on the same side. And so another time we rotate one side electron densities, so we get this is what CH3 and this is what H is there. This is the transform is there, transform. Okay, IUPAC name also we have to write. A structural formula is ready. Okay, possible number of structure we are getting 1 2 3. If you consider isomer, so then you are no, if you are considering cis and trans, so these two structures we have. Okay, this is the cis form, this is the trans form, and naming is done. So numbering you have to do from this side, 1 2 it is 3 and it is 4 is there. Okay, from the side where the double bond gets the lowest numbers. So how many carbon are there? 4 carbon. We can say but 1 in, or butene also we can mention. But 1 in. 1 in means it is specifying the position of double bond in the chain. In this case you can do the numbering from any side because it is a symmetrical compound. 1 2 it is 3 and 4 is there. So we can mention but and it is 2 in is there. But 2 in. In this case you need to mention 2. You cannot mention butene. Okay. But 2 in. Name of the compound will be but2in. Okay, now let's say we have to do the naming for this compound. We have to do the naming for this compound. So how we can do? Let's say we have CH3. I can write C and double bond. It is CH2 is there, and here we have CH3 here. We can do the numbering. 1 it is 2 and it is 3 is there. This is the parent chain for us. Okay, and branching we got at the second carbon. So we can mention 2 methyl is there, 2 methyl Okay, and in the parent chain how many carbon are there? 3. So we can mention prop, and we can mention 1 ene is there, prop 1 ene. 2 methyl prop 1 ene is there. Yeah, propane also can be mentioned because at the terminal carbon double bond is present. Okay, so first compound is done. Now we move on to the next one. We have C5H8 is there, C5 and it is H8. In this case, one triple bond is present. It does not mention double bond is also present, only one triple bond. Okay, so we have C, how many carbon? 5 carbons are there. 1, 2, 3, 4, 5. So I mention triple bond at the end. Okay, satisfy the valency of carbon by attaching hydrogen. It is H2, it is also H2, and here we got H3 is there. Okay, one compound we got. And then I shift this triple bond to the second carbon. Then we have C, C and C and C, 4 carbon, 5th carbon, triple bond I mention here. Okay, satisfy the valency of carbon. CH3 is there, and we have CH2 and it is H3 is there. Total number of hydrogen 8. 3 plus 3 plus 2, 8 is there. Okay, now if I do the shifting of this triple bond to this carbon, compound will be same only, because in that case you have to do the numbering from this side. Okay, so we can do the branching now. So branching in the sense we can introduce iso group C, and it is C and it is C. Okay, and we have C triple bond, it is C is there, 5 carbons we need. Okay, we have H, valency satisfied, it has 1 hydrogen, 3 hydrogen, it is also having 3 hydrogen. Okay, 3 hydrogen is there. 3 hydrogen, clearly I can write that CH is there. Okay, another branching is not possible because you can see carbon is having 4 bond. If I mention, let's say if I shift this triple bond here, and this carbon is already forming 3 bond, carbon cannot form more than 4 bond. Okay, so shifting of this triple bond at this place will not be possible. Okay, these 3 structures we are getting. We can do the naming also. So we have to do the numbering from this side, so that triple bond should get the lowest number. 1, 2, and it is 3, 4, and it is 5 is there. We can mention pent 1 ion is there. In the first position you can see triple bond is present, ion, pent 1 ion. In this case 1, it is 2, 3, 4 and 5. Keep in mind you cannot do the numbering from the left to right, because if you do the numbering 1, 2, 3, 1, 2, 3, in the third carbon double bond triple bond is coming, but from this side second carbon triple bond is coming. We always allocate minimum number to the functional group. So in this case we can mention pent 2 ion is there, pent 2 ion. We have pent and it is 2 ion is there, and in this case pent 1 ion is there, pent 1 ion, pent 1 ion. Okay, pent 1 ion is there. Pentyne also we can mention, no problem. Now we have a first carbon, second carbon, third carbon. Let's say this is fourth carbon, and this is the branching we have. So we can mention 3 methyl. We have 3 methyl. Now how many carbon are there in the parent chain? 4 carbon. So we can mention bute, and then we have 1 ion is there, 1 ion. So name of the compound 3 methyl bute 1 ion. If you like this video, please share and subscribe to the channel.